Hello everyone, this is a video lecture for College Algebra Math 1314 Section 4.1. We're going to be doing exponential functions today. So, question 1 is basically just saying, hey, find out what these values are from a calculator. I'm not going to show you a calculator. I'm just going to do it in my calculator because it's that simple. These questions are not meant to be hard. They're meant to show, hey, do you own a calculator? Because you're going to need one. That's really all these questions are doing, is kind of saying, hey, get a calculator out because you're going to need it going forward. And it's also kind of saying, hey, does your calculator do this? Can you show yourself that you can use this calculator in this way? That kind of thing. So round to whatever decimals they're asking for. You're done. Next question. All right, so we're going to use the calculator again, and this is kind of with a graph attached to it, but we need to find these values first. All I'm doing is plugging in these values, so -2, so I would get 9 fourths to the -2 power. I put that in the calculator. I'm doing it right now myself. -2, and I got 16/81. And it's important that you're doing fractions and stuff like that. So we need to be able to have a calculator that will reduce this down to fractions. I personally recommend Desmos.com. It's free, it's super easy. The scientific calculator does all this for you. So yeah, definitely get a calculator that can do some fractions for you. And of course, if you do -1, what it's going to do is flip this guy, so it would be 4/9. Anything to the 0 power is 1. Very good. Anything to the 1 power is itself. And then whenever you square it, then you're going to have that 81/16. It's kind of like the opposite of this one. So there's all your answers, and they're going to say graph this thing, and it does this. So match up, like, the dots with the dots that you just found, that kind of stuff. I'm not too worried about it. It's just a multiple choice. Keep moving. All right, it says graph all of these now. And honestly, I would say go to a graphing calculator, put these in, and you're done. That's not very hard. They're wanting you to use transformations. I'm going to use transformations here just because I don't want to pull up a calculator. I want to just do this with you. So the very first one that you should look for, because they're a little bit, I guess the arrangement is not always this way in your homework program. So you have to kind of like find the one that you need, and this is the original. So we're going to do that one first, and it looks like this. Okay. Now I know that's kind of basic, and it's like, well, yay. What is it doing? Well, it's going to be important to have the original, because then after that, you should be able to move it around and change it. You're always going to be going through 1 right here, and at x equals 1, there's no way I could show this to scale, I guess, you're going to be at a height of 8. And why 8? It's because if I were to really graph this thing, it would be like really, really tall, because there's 1, and then at 1 right here, you're already like at 8 way up here. So I guess that's a better one. Okay, so this is my original, and now I'm going to move it around. So I have a negative with the x, and it's going to flip it side to side. And so I'm just going to do a quick one. It's going to look kind of like this. This one here flips it upside down. So again, my original was there, so now it's going to go down here. This one flips it twice, so it actually looks something kind of like that. This one has been shifted down, and so it's going to be shifted down a little bit. And this one's shifted to the right. Now, this one's the hardest one to identify, because let's just, take my original here, and I'm going to shift it to the right by 1. I'm going to shift it to the right by 1. There you go. I guess that's close enough. They look very similar, and this one here is going through at 1, and this one's not. Now, where is he going through? It doesn't really matter. The point is that your 1 height is shifted over at 1. So you should be at 1, 1 here, while this guy here, your original, is at 0, 1. And that's the kind of the only indicator to know between those two. It's really difficult to tell the difference, but that's how you do it. Put them all in. You're done. All right, compound interest. So this is a application of these exponentials. And I just want to say, like, there's a lot going on here, obviously. We got two formulas. There's this regular one, and then we got the continuous compounding formula. We'll focus on that here in a minute. But basically, here's all my things. So A is my final amount. P is my principal, or your starting amount, initial amount. R is your rate in decimal form. T is your time in years. And then N, which you see is right here and here. This is what's changing in this particular problem. It's the number of times compounded per year. So they're going to say quarterly, monthly, daily, semi-annually, annually, those kind of things. And you got to interpret N from that English. If you don't have an N, or if it's basically just as continuous, then you're going to use this formula. Obviously, it doesn't have an N for you to plug in there. So let's do this problem. It's really not too hard, but you'll definitely have to use calculator. So let's put all this stuff together. We got my principal is $20,000. My time is 7 years, and my rate is not 4.5. It's 0.045. It's an important distinction there. You got to convert your percentages into decimal form. And so semi-annually is when n is equal to 2. And what I'm going to do is put this all into my calculator. Let's just say Desmos. And you have to type it all in there and get an answer. The good thing about calculators online, kind of like Desmos, is that this is semi-annually, so put a 2 there. 2 and then a 7. The good thing about Desmos is that you can put in this, I guess, big formula, hit enter, and then you can go back and edit it, and you'll just change this 2 to a 4. You change that 4 to a 12, yada, 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 and you can get some easy answers out of that. So I just was plugging it in to this formula here, P1, R, and I do have one small warning about calculators, and especially Desmos, since I've been mentioning it. It does not like you doing this kind of thing in the power. What it's often going to do is you'll put a 2, and then the 7 will be down here, and it is very frustrating trying to put in 2 times 7 in the power. If you want to, there's 2 different options. You could just say in parentheses 2 times 7. So like when you're in the power, you just start with a parentheses and start it, and then you type your math and then close it with a parentheses. So that's one way, and that's okay, totally good. The other way is just simply saying, well, I know that's 14, so put a 14 up there. I recommend this one often, so it's really up to you, but make sure that the 7 is not dropped down here. That would change your entire answer, and you're like, why am I getting the wrong answer all the time? Well, it's because the Desmos isn't doing it right. Now, it depends on the calculator, obviously. I just know personally that Desmos does that nature. Maybe some other calculator that you have does not. I don't know. But Desmos is great. I still recommend you using it. It's just quirky sometimes, rarely. And this is one of those rare instances where you just have to learn the quirks. Anyways, let me put this whole thing in to my calculator that I have here. 1 plus 0.045 divided by the 2, and then all to the power of, and I often like putting parentheses up there anyways. I got 27309.67 rounded. So I round the 2 decimal places because it's dollars and cents. And there you go. That's your answer for part A for the semi-annually. N equals 2. All right, cool. Well, to be able to do the other ones, quarterly means n equals 4, and you're just going to copy-paste this whole formula down and just change that 2 to a 4, and then you're going to do it again. So monthly is going to be a 12, and you're going to do it again, change that 2 or that 4 into a 12. We'll talk about the continuously here in just a second. So I'm just going to, my calculator has everything in there still, so I'm just going to change that 2 to a 4, and I got answer of 27,357.03. Okay, again, this is dollars and cents. And then for the 12, just changing my 4 to a 12, I wish I could show you this stuff, but it's not on a technology side that I can't. I'm just making sure that we are all on the same page mathematically. Let's just say that. So it's not exactly my preference, but I mean this is a fine format. Um, so there's my three answers. Again, you can see they're getting a little bit bigger each time because you're going to check over it a little bit more. Anyways, continuously has a different formula entirely, and I want to do that with you right quick. So I'm going to rewrite my formula. Sometimes people call it the PERT formula because it says PERT. But either way, 20,000, then a little e, and then your rate is going to be 0.045, and then you say times 7. Again, watch out. If you're doing Desmos, it might keep it up there this time because it's an E and it understands. It might not, and it'll drop it back down like normal. Just learn the tools that you're learning on. And if that's Desmos, which I recommend, you just got to learn what Desmos does. All right. I got 27405.19 rounded. Okay, awesome. And, well, that's the end of that problem. I know it's a little bit looking haphazard, but in the end, you're just putting it into a formula, and you just change one number. It really is all that, okay? So there's your compound interest. Let's go to the next one. And I think this is the last one, actually. No, I got two. I got another one past this. Anyways, so they got two models here. This is a linear model because it does the mx plus b stuff. This is an exponential model because, well, it has e. But it also has the exponent, but e stands for something else entirely. But they're wanting to say that x is years after 1980 and that we're now in 2005, find out what values you'll get. Well, 2005, your x should be 25, I believe. And so what you're going to do is plug in 25 to each of these. So this is going to be 25 plus 26. That's 51. That was easy. This one here, you're going to plug in the 25, so 30.8 e 0.0216 times 25. Calculator. You can see that we've been using our calculators a lot, and that's why the very first problems, again, we're saying, hey, do you own a calculator? Do you have a calculator that can do this kind of stuff? As you can see that, well, it's important. We've been doing it on every problem nearly. So there you go. Round to whatever the homework program's telling you to do. And this is compared with the chart. Well, notice that they had a 55. And so which is closer? Which of these is closer? Well, 52 is closer to 55. I know it's not much closer, but it is closer. And so I would say the exponential model because that's the one that's closer. Keep moving. Okay. And now this is the last one. And it's a little weird, and I would definitely recommend a graphing calculator for this. Before we can do it, though, we need to create these formulas. They're very picky about wanting a formula in a very particular way. So let's go through and try to figure that out. Because we have quarterly and monthly, there's a lot going on here. We got n equals 4 here. We got n is equal to 12 here. My percentages look kind of strange, but my rate would then be a 0, 0, 4. Yes, yeah, because you're moving this 2 places over, and you can see we got 0, 0, and then a 4. And the same with this one here. So my rate would be 0, 0, 3, 9. And they are very close numbers to one another. So I'm expecting very similar results. But again, we need to do the formulas first. We're starting with $13,000. I'm going to just say A and B. So A equals this, B equals that. 1 plus 0.004, all over 4 for quarterly, and then 4 times T. Did you notice that they didn't have a time in here, right? And that's going to be one of those tricky elements because it's a formula. You're not actually solving for an amount yet. So what they want, what the homework program's wanting you to do is simplify this inside to a decimal. And so what I'm going to have is a 1 plus 0.004, and then divided by that 4, and I've got decimals. Let me write this whole thing down here. 1.001 to the 4t. That t look a little bit better. Okay, that's close enough. And there you go. That's their answer. So this is your part A formula, I guess. So that's what we're looking for. The bank B formula would be very similar, obviously, 13,000. And then we got 1 plus 0.0039 all over 12, and then 12t at the top. Again, you only need to simplify the inside there, and so I'm not typing all of this in to my calculator. I'm only typing the inside of that parentheses. That's it, because that's all I'm concerned about. And decimal-wise, I got 1 point, it's going to be a lot here, 0.000325. And yes, they want every single decimal there. No rounding. Just as you see it. This is it. This is it. That's your answer to part B. So that's a lot. We're not done yet. And this is where this goes a little bit differently. It goes a little bit astray. It says find the graphs. And they give you some coordinates to follow. And I don't know those exactly right now. I didn't have them written down, but I want to just remind you what this looks like. So let's just say that we had something like this, and then it said also something kind of like this here. Again, I'm just going to make something up. Okay, something like that's good enough. What are they trying to say when they get this stuff? Again, we're looking for the graph, and they give me these kind of numbers. It's kind of weird looking. Well, this is the x values, and this is the y values. They might say something like that there. What they're trying to get at is that you're going to start here at 0, and you're going to end at 10, and this is your step or tick mark or something like that. Essentially, it's going to be a number line starting here at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you're done. That's where you're going to be looking at your graph. So that's the bottom horizontal axis stuff. The y values are similar, so we're going to start at 0, but then we're going to end at 100,000. And so what would that even look like? Again, this is vertical. So we're going to start here at 0, and every tick mark, every step, I didn't write step correctly, every step is 10,000, and you're going to go to 100,000, so there's 10 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But that's not 10. That's actually 100,000 up here. And so when you put these two together, what you would get is some kind of graph that goes out here to 10 and something that goes up to 100,000. And this is the entirety of the graph. This is where you're looking, is right here. And of course, you got tick marks all over the place. And what they're trying to get at is that we're going to have to get started at some point, and that's like down here at the 13,000, because that's where we're starting, obviously. And then we're going to exponentially grow from that point. You have to kind of know these window settings in order for this graph to kind of work out, because what's going to happen is it looks kind of like this, and then it's going to look like this. Okay, so there's your answer for this problem. Yay, pick that one. Okay, but the thing is that it could be different in the future. So other examples could be this and this. So that's another example that could work. Another one could be this and this. There's a lot of different options, and it kind of depends on what you have for your window settings. And so this particular one, when I put in the window settings, again, I can't remember if it was 100,000 or not, but you put it in, and it's supposed to look something kind of like this here, I guess. And that's the point. You just click the one that looks like the actual graph that you typed in. If you didn't have the window settings, it'd be very difficult to see exactly what they're going for. Even in Desmos, where you can zoom out, it's not exactly correct until you put in the right window settings. Anyways, click the right graph eventually. And then they're going to ask, well, which one's better? Which one's better? And to do this, I think Desmos is actually really good at doing this. What you would do in Desmos is you have two different colors. This one, like here, I'm going to demonstrate. We got, say, a red one and a blue one. So like the top one here is red and the bottom one is blue. And you're going to say, oh, well, which one's better is the red one. This one's better because it's on top. It's getting more dollars, more dollars. So then you go back and say, oh, well, what was the red one? And the red one ended up being your bank A in this particular case. So bank A is the correct answer for that. But you have to kind of see color-wise, and a normal TI or Casio graphing calculator is not going to show you those same colors, really. But the Desmos will definitely show you those colors, and it's a much easier problem in that case. So now you know the technicals. The main thing from all this, I would say, get a calculator, and I recommend Desmos. That's all I got. Thank you very much. Have a great day.